So just going to look at evaluating i's. Now, I squared would just be minus 1, because it's root minus 1 times root minus 1, which just gives you minus 1. You just get what's under the square root. If you went I3, that's the same as having I squared times I, so it's minus 1 times I, so you just get minus I. What happens though if you had I to the 4? So that would be I squared times I squared, which would be minus 1 times minus 1, which is plus 1. And I to the 5 would be I times I to the 4. I to the 4 is 1, so it's just going to be 1 times I. Okay, let's just say we have I to the 6. That would be I to the 4 times I squared. So it's 1 times minus 1, which is minus 1. And hope we can see there's a bit of a pattern here now. Okay, if we look at I to the 7, so take the odd one out, which is I, and then you have I to the 8. But I to the 8 is like I to the 4 times I to the 4, which are both 1. So you get I. Okay, if you get I to the 8 would be I to the 4 squared, which is just 1 squared or 1. I to the 9, once again, take the odd one out, and you got I to the 8, so you just I. So you can kind of see there's a bit of a pattern here. If it is an even number that is divisible by 4 on the power, then I to anything divisible by 4, like say 4n, will just be 1. For example, I to the 2000. 2000 is divisible by 4, so it'll just be 1. Okay, but if it is just even, but not divisible by 4, then it just ends up being minus 1. So for example, I to the 6 was minus 1. If it was to the 66, it would still be minus 1. If you had an odd power, then what you need to do is you need to take the I out of it, and then you have to just see, is it divisible by 4 or not divisible by 4? So let's just say it was 17. That would be I times I to the 16. 16 is divisible by 4, so that would be 1. But if you had I to the 23, then that would be I times I to the 22. And I to the 22 would be minus 1 because it's not divisible by 4. So therefore it'll just be minus I. And there they are basically your different options.